Good evening. Welcome to Unacademy Ascend YouTube channel. This is Umamaheswara Rao. One important announcement. Unacademy Combat goes live on 29th December at 6 p.m. It is a free live combat. You can register now. Use code KUR75. Register for Unacademy Combat. December 29th at 6 p.m. I am coming up with a new course on Unacademy Plus. Course on Engineering Mathematics for GATE 2022. Course starts from 1st January. Timings 6 p.m. to 8 p.m. I am coming up with another new course, that is practice course on engineering mathematics for XE, Engineering Sciences for GATE 2021. Course starts from 1st January. Timings 8:30 p.m. to 10 p.m. Now, in 2 months crash course, I will be discussing continuous probability distribution. Today I will be discussing continuous probability distributions. In continuous probability distributions, uniform distribution, exponential distribution and normal distribution. In the previous lecture, we have discussed binomial and Poisson. Those are discrete distributions. These are continuous probability distributions. In continuous probability distribution, first one, uniform distribution. Why it is continuous probability distribution means random variable x takes values in an interval. Any random variable takes values in an interval, it is continuous random variable. Whenever random variable is continuous random variable, x follows, x takes values in an interval. Now, if x follows, random variable x follows uniform distribution in the interval a to b. If x follows uniform distribution in the interval a to b, then the probability density function is given by f of x is equal to 1 by beta minus alpha. Here I have mentioned a and b, that's why I am writing 1 by b minus a A less than or equal to X less than or equal to B. Now, mean of uniform distribution is given by, whose mean is given by A plus B by 2, whose variance is given by B minus A whole square by 12. If X follows uniform distribution in an interval AB, then the probability density function is given by 1 by B minus A, whose mean is A plus B by 2 and whose variance is B minus A whole square by 12. Now, problems on uniform distribution. Now, buses arrive at a specified stop at 15 minutes intervals. Starting from 7 a.m. That means 7 a.m., 7:15 a.m., 7:30 a.m., 7:45 a.m., like that. If a passenger arrives at the stop at a random time, that is uniformly distributed between 7 a.m. and 7:30 a.m. the probability that he waits less than 5 minutes for a bus. He waits less than 5 minutes for a bus. So here random variable follows uniform distribution in the interval 7 a.m. to 7:30 a.m. total 30 minutes. So X follows uniform distribution in the interval 0 to 30. Yeah, 7 o'clock to 7:30 means 0 to 30 minutes. So I am writing X follows uniform distribution in the interval 0 to 30. Therefore, the probability density function is f of x is 1 by 30. So 0 less than or equal to x less than or equal to 30. Now, the passenger waits less than 5 minutes. The passenger waits less than 5 minutes means it is possible only when if he arrives. If the passenger arrives at the bus stop between 7:10 a.m. to 7:15 a.m. or 7:25 a.m. and 7:30 a.m. Suppose if the passenger arrives at the bus stop between 7:10 a.m. to 7:15 a.m. or 7:25 a.m. to 7:30 a.m. then only you can say that he will wait less than 5 minutes. That's why we have to calculate probability that x varies from 10 to 15 r means plus 25 to 30. Now integral 10 to 15 1 by 30 dx f of x dx 25 to 30 1 by 30 dx, that is integral dx is x 10 to 15, integral dx is x 25 to 30, that is 5 by 30 plus 5 by 30, that is 10 by 30, that is 1 by 3. So the required probability is 1 by 3. Next column, a random variable is uniformly distributed over the interval two to 10. Its variance will be, first option 16 by 3, 6, 256 by 9, 36. Yeah, it is a problem designed on simple formula. If x follows uniform distribution in the interval 2 to 10, if x follows uniform distribution in the interval 2 to 10, then the variance will be given by variance is b minus a whole square by 12. So here 10 minus 2 whole square by 12, 8 square by 12, 64 by 12, 16 by 3. So here the variance is 16 by 3. Next column, a point is randomly selected with uniform probability in the xy plane within the rectangle with corners at 0 0 1 0 1 2 and 0 2. If P is the length of the position vector of the point, then the expected value of P square is a point is randomly selected with uniform probability in the xy plane within the rectangle with corners at 0 0 1 0 1 2 and 0 2. If P is the length of the position vector of the point, then the expected value of P square is a point is randomly selected with uniform probability in xy plane within the rectangle bounded by x equal to 0, y equal to 0, x is equal to 1, y is equal to 2. The length of the position vector of the point. He has mentioned the length of the position vector of the point is P. Randomly, if you select any point, if the point is x comma y, the length of the position vector of the point is P. So 0 comma 0 to x comma y, the distance is P. Length is nothing but the shortest distance between origin to the selected point. Yeah, the point is selected with uniform probability within the rectangle with 4 corners 0 0 1 0 1 2 0 2. So that is nothing but the rectangle bounded by x equal to 0, x equal to 1, y equal to 0, y equal to 2. Now P is the length from the origin to the selected point x comma y, that the shortest distance between 0 comma 0 to x comma y is square root of x square plus y square, but you have to find expectation of p square, expected value of p square. That's why I am calculating p square. P square equal to x square plus y square. Now expected value of p square means expectation of p square. Expectation of p square equal to, observe here, I am writing on the next slide. Observe, expectation of p square equal to expectation of x square plus expectation of y square. As per the definition of expectation, in the case of continuous random variable, here x is continuous random variable because x varies from 0 to 1 in an interval. That's why integral 0 to 1 x square into f of x dx plus y varies from y equal to 0 to y equal to 2. That's why y varies from 0 to 2. So integral 0 to 2 y square into f of y dy. Now what is f of x and what is f of y? You can find out very easily with the help of this diagram. Observe here, x follows uniform distribution in the interval 0 to 1. Y follows uniform distribution in the interval 0 to 2. When x follows uniform distribution in the interval 0 to 1, f of x is given by 1 by beta minus alpha b minus a 1 minus 0, that is 1. When y follows uniform distribution in the interval 0 to 2, f of y is 1 by beta minus alpha 1 by 2 minus 0 1 by 2. Now f of x is 1, f of y is 1 by 2. Continuation, that is integral 0 to 1 x square into 1 dx, integral 0 to 2 y square into f of y is 1 by 2, so 1 by 2 dy. Continuation, integral 0 to 1 x square dx is x cube by 3 from 0 to 1. 1 by 2 into y cube by 3 from 0 to 2. Applying upper limit and lower limit, 1 by 3 plus 1 by 2 into 8 by 3. 1 by 3 plus 4 by 3, that is 5 by 3. Next column, suppose you break a stick of unit length at a point selected uniformly at random, then the expected length expected length of the shorter stick is. This is keyword. That is keyword in the problem. Suppose you break a stick of unit length at a point selected uniformly at random. Then the expected length of the shorter stick is. In this problem, random variable follows uniform distribution. In which interval? I have underlined a line shorter. The word shorter, the reason is stick of unit length. Definitely Roshan. In this problem, suppose if you take a stick of unit length, zero, 1. Suppose if you break the stick at a point P. Now left side part is shorter or right side part is shorter is decided by whether the selected point is left side of 50% or right side of 50%. Based on that, we are going to select which part is shorter. That's why the selected point is less than 50%. Right? The selected part is less than 50%. That part is treated as shorter part than the larger one. Okay. Therefore, random variable, suppose if you say length L follows uniform distribution in the interval 0 to 50%, 0 to half. Therefore, the probability density function is f of L equal to 1 by 1 minus 2 minus 0. That is 1 by 1 by 2, that is 2. Now, expected value of L, E of L is given by integral 0 to 1 by 2 L into f of L dl. Integral 0 to 1 by 2 L is L, f of L is 2 dl. That is 2 into L square by 2 from 0 to half. We can cancel this 2 and this 2. If you apply the limit, L square is nothing but 1 by 2 whole square minus 0, that is 1 by 4, that is 0.25. Roshan, you watch previous videos. Last month I took completely MSQs and NATs. This is a 2 months crash course on engineering mathematics for GATE 2021. Next one. Exponential distribution. If random variable follows exponential distribution, the probability density function of exponential distribution is given by f of x is equal to lambda into e power minus lambda x greater than or equal to 0 otherwise. If random variable follows exponential distribution, the probability density function of exponential distribution is given by lambda into e power minus lambda x greater than or equal to 0 otherwise. Whose mean is 1 by lambda, whose variance is 1 by lambda square. The mean of exponential distribution is 1 by lambda and variance of exponential distribution is 1 by lambda square. First problem. Assume that the duration in minutes of a telephonic conversation follows exponential distribution f of x equal to 1 by 5 into e power minus x by 5 x greater than or equal to 0. The probability that the conversation will exceed 5 minutes is option A 1 by e, 1 minus 1 by e, 1 by e square, 1 minus 1 by e square. So in this problem, random variable follows exponential distribution f of x equal to 1 by 5 into e power minus x by 5. The probability that the conversation will exceed 5 minutes is, so we have to find out probability that the conversation will exceed 5 minutes. So integral 5 to infinite f of x dx, integral 5 to infinite 1 by 5 into e power minus x by 5 dx, e power minus x by 5 by minus 1 by 5 from 5 to infinite. Now this can be written as minus of e power minus infinite e power minus 5 by 5 minus 1. 0 minus 1 by e, that is 1 by e. 1 by e is nothing but 0.36937. So correct answer is 1 by e. Sagar, complete revision course I have planned in the month of December, right? So almost all batch is about to close by tomorrow, day after tomorrow. Complete engineering mathematics is revised in that course. You can watch the recorded videos. One complete course and one revision course. Next problem. Let Z be an exponential random variable with mean 1. The cumulative distribution function of Z is given by fz of x equal to 1 minus e power minus x greater than or equal to 0, which is 0 if x less than 0. Then probability of z greater than 2 by z greater than 1 is. In this problem, the cumulative distribution function is provided. We have to calculate probability of z greater than 2 by z greater than 1. So here random variable follows exponential distribution. The cumulative distribution function fz of x is 1 minus e power minus x when x greater than or equal to 0. Which is 0 when x less than 0. Now, probability density function is small f of x equal to d by dx of capital F of x. Differentiation of distribution function is density function. That's why I am differentiating. Differentiation of 1 minus e power minus x is e power minus x when x greater than or equal to 0, which is 0 if x less than 0. Now, we have to find out probability of z greater than 2 by z greater than 1. The conditional probability of z greater than 2 by z greater than 1, that is nothing but z greater than 2 intersection z greater than 1 by probability of z greater than 1. Observe here. Suppose this is 0, this is 1, this is 2. Z greater than 1. Z greater than 1 means right side of 1. Z greater than 2 means right side of 2. Z greater than 2 intersection Z greater than 1 means which part is common? Intersection. Common to both z greater than 2 and z greater than 1. So from here onwards it is common. That's why I am writing probability of z greater than 2 by probability of z greater than 1. This can be written as integral 2 to infinite density function f z of x dx by integral 1 to infinite f z of x dx. So density function is, this is capital Fz, this is small fz. Now you require density function. That's why you have to write integral 2 to infinite e power minus x dx by 1 to infinite e power minus x dx integration e power minus x by minus 1 from 2 to infinite by e power minus x by minus 1 from 1 to infinite, that is minus of e power minus infinite is 0 minus e power minus 2 by minus of 0 minus e power minus 1. Continuation. E power minus 2 by e power minus 1. 1 by e square by 1 by e by e square, finally 1 by e. 1 by e is nothing but 0.37. So final answer is 0.37. Understood? This was given in 2019 EC. Next, normal distribution. The probability density function of normal distribution is given by f of x equal to 1 by sigma root 2 pi e power minus 1 by 2 of x minus mu by sigma whole square minus infinite less than x less than infinite, whose mean is mu. Whose variance is sigma square. Mean is mu and variance is sigma square. Now, normal curve is symmetrical about its mean. Normal curve is symmetrical about its mean mu. Total area under the curve is 100%. Left side of mean 50%, right side of mean 50%. That is, this is x equal to mu. Left side of mean, this part 50%, this part 50%. So the mean median mode of normal distribution are always equal. Mode is equal to median equal to mean. That is speciality of normal curve. Another thing, the area bounded by mu minus sigma to mu plus sigma mu minus sigma, mu plus sigma. The area bounded by mu minus sigma to mu plus sigma is 68%. The area bounded by mu minus 2 sigma to mu plus 2 sigma 95%. The area bounded by mu minus 3 sigma to mu plus 3 sigma is 99.7%. The area bounded by mu minus sigma to mu plus sigma is 68%. Mu minus 2 sigma to mu plus 2 sigma is 95%. Mu minus 3 sigma to mu plus 3 sigma is 99.7%. Now, first column, the standard the standard normal probability function can be approximated as f of xn equal to 1 by 1 plus exponential of minus 1.7255 xn modulus of xn power 0.12, where xn is standard normal deviate, standard normal deviate. If mean and standard deviation of mean and standard deviation of annual precipitation the mean and standard deviation of annual precipitation are 102 centimeters and 27 centimeters respectively. The probability that the annual precipitation will be between 90 centimeters and 102 centimeters is option A 66.7%, 50%, 33.3%, 16.7%. Now, in the data it is given that the normal probability function, the standard normal probability function can be approximated by f of xn if mean and standard deviation of annual precipitation are 102 centimeters and 27 centimeters respectively. Then the probability that annual precipitation will be 90 centimeters and 102 centimeters. So here simply you can understand that the cumulative probability distribution function is provided here, and the probability distribution function and the normal probability function both are approximately same. Therefore you can understand that x follows normal distribution with mean 102 centimeters and standard deviation sigma 27 centimeters. So if random variable follows normal distribution with mean 102 and sigma 27, then the probability that annual precipitation will be 90 centimeters to 102 centimeters. We have to find out probability of 90 less than x less than 102. Probability of 90 less than x less than 102. This is mean line. X equal to mu is nothing but here 102. This is mu plus sigma. Mu minus sigma. Mu plus sigma means 102 minus 27. 102 minus 27 is 75. Mu plus sigma is 129. Now observe here, we know that probability of mu minus sigma less than x less than mu plus sigma is 68%. Therefore, in our problem, probability of 75 less than x less than 129 is 68%. So mu minus sigma to mu plus sigma is 68% means mu minus sigma to mu. So probability of 75 less than x less than 102 is 34%. Right? Mu minus sigma to mu plus sigma, 75 to 129 is 68%. So 75 to 102, 34%. But you have to calculate probability that x varies from 90 to 102. X is 90 to 102. This part you have to find out. So 75 to 102 is 34%. So probability of 90 less than x less than 102 is, by using options I would like to solve. In the options, 66.7% no, 50% never, 33.3%. Observe here, 75 to 102 is 34%. So 90 to 102 is not 33.3. It is not 33.3. It can be 16.7%. Because 75 to 102 is 34%. So 90 to 102 compulsory less than that, approximately closer to 17%. Therefore, I have selected 16.7%. Closer to 17%. That's why 16.7% is the correct answer in this problem. Understood? Next problem. Let U and V be two independent zero mean Gaussian random variables of variances 1/4 and 1/9 respectively. The probability of 3V greater than or equal to 2U is, first option 4/9, 1/2, 2/3, 5/9. Now, here let us take random variable x equal to 3v minus 2u. Now expectation of x is expectation of 3v minus 2u, that is 3 into expectation of v minus 2 into expectation of u. This is 0. This is e of u is also 0, that's why finally 0. Expectation of x is 0. Now zx, I am converting into standard normal variate, x minus mu by sigma. So here x minus mu by sigma, right? So here x value 3v minus 2u, here x minus mu, so mu is mean of x is 0, so x minus 0 by sigma, right? So here probability of 3v minus 2u greater than or equal to 0, we have to calculate. Observe here, probability of 3v greater than or equal to 2u. So probability of 3v greater than or equal to 2u is nothing but probability of 3v minus 2u greater than or equal to 0. That means probability of x greater than or equal to 0. Random variable follows normal distribution. We have to calculate probability of x greater than or equal to 0. Observe here. Random variable follows normal distribution. Probability of x greater than or equal to 0, whose mean is 0. Here x is equal to 0. We have to calculate probability of x greater than or equal to 0. Greater than or equal to 0 means right side of 0, this part. By the property of normal curve, left side of mean and right side of mean, the probability is 0.5. Therefore, probability of x greater than or equal to 0 is 0.5. So correct answer is 0.5 or 1 by 2 in this problem. Understood?
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Next live combat will be on 29th at 6 p.m. Dear students, it is a free live combat. Attend the test in 3 streams: electrical engineering, mechanical engineering and civil engineering. Utilize the opportunity. Thank you.